So today we're going to start talking about learning target 7, which is about graphing a quadratic function and identifying the relationship between the graph and a shift in the equation of the graph. First of all, to graph a quadratic function, you always need at least 3 points. You can have more than 3 points, and the more the better, because it's going to give you a more accurate graph. But you need at least 3. Just like for a line, you need at least 2 points. There is a different strategy for graphing each type of equation, though: vertex, factored, and standard. In this first part, we're just going to talk about vertex form. In vertex form, so if you remember, vertex form is this, that. The H is a horizontal shift, and the K is a vertical shift, which means whatever H is, that's going to slide it left and right along the x-axis, and whatever K is, that's going to tell it to go up or down along the y-axis. So to graph a function in vertex form, you're first going to graph the parent function at the origin with the appropriate a value. So to do this, you're just going to make a table. If you're looking at this function right here in vertex form, the parent function is going to be without the shifts. So basically no H, no K. So here, it's going to be that, 2x squared. And then, once you have the parent function, you're going to make a table of that. And I'm going to go from -2 to +2. That way it gives me some negatives and some positives. And I'm just going to plug each of these values in for x to figure out what they equal. So -2 squared, that's going to look like this. Make sure you put the -2 in parentheses, because otherwise you're going to get a different value. So -2 squared is 4, and then 4 times 2 is 8. So if you plug -2 into this function for x, you end up with 8. If you plug -1 in, -1 squared is 1, and then 1 times 2 is 2. So you get that. 0 squared is 0. 0 times 2 is 0. 1 squared is 1. 1 times 2 is 2. 2 squared is 4. 4 times 2 is 8. So you can make a table pretty quickly because there's not much to figure out when you plug things into the parent function. And then you're just going to plot those points. So you get -2, 8, -1, 2, 0, 0, 1, 2, 2, 8. So that's going to be your parent function without the shifts. Now what we're going to do is we're going to graph the function with the shifts. So this function right here is moving 3 spaces to the left. Because of that's a -k in our original function, this is going to be opposite direction that you would think. So you'd think it'd take the point and move it 3 in the positive direction because it's +3, but it actually moves it in the negative direction to the left. So this function is going to be moving 3 to the left and then down 1. So left 3, and that tells us down 1. So I'm going to pick at least 3 of these points, if not all of them, and I'm just going to move them all left 3 and down 1. So this function, or this point right here, is going left 3, down 1. This one is going left 3, down 1. This one is going left 3, down 1. This one is going left 3, down 1. And then left 3, down 1. So this is the actual function. And I'm going to make sure to make that one darker because that's like my real final function. This is just kind of like the shadow that got me there on the way. Okay? So this is my real function. And that's how you can graph in vertex form. First you do the parent function with the a value, and that's going to help you make a quick table. And then just shift all the points. according to what these are. This is shifting left to right and the opposite of what you would think. This one's shifting up and down.